Hello, Math 1 CP. This is Mr. Roberts, and this is a look at the study team test that we passed out on, I guess, Wednesday. So I'm going to go through the answers here. This first question is a matching question, and there's several choices on the right-hand side, equation choices, and there's descriptions on the left. And we're going to select equations and write them in there. So let's go through and look at these. I think probably the easiest thing to do that would kind of facilitate answering this question is to begin by changing each one of these equations into slope-intercept form. It's a lot easier to see things about the equation if it's in that form. One of them already is in slope-intercept form. You can see this one is in y equals mx plus b form, so I'll leave that alone. That equation has a slope of 2/3 and a y-intercept of 2. So if I look at the top equation, I'm going to go ahead and subtract x from both sides. So it's going to become 5y equals negative x minus 16. And if I divide everything on both sides by 5, I get y is negative 1/5 times x minus 16/5. So that is that top equation in slope-intercept form. I can see its slope pattern is down 1 over 16. And its y-intercept is at negative 16/5. The other one that I'm going to manipulate is this one, right? And it's this one right here. To get this in slope-intercept form, I just need to take away x from both sides. So it's going to become y is equal to negative x and then plus 1/3. So for that equation, my y-intercept is at 1/3. And the slope pattern for this is down 1 over 1, right? It's got a slope of negative 1. Next one we'll do is this negative 2x plus 6y equals 24. So I'm going to add 2x to both sides. This becomes 6y is equal to 2x plus 24. And if I divide everything by 6, right, the equation I get is y is equal to 2/6 x plus 24 divided by 6 is 4. The other thing that's true is this 2/6, right? You can see why I got it because I divided everything by 6. In fact, I'll write it this way. I'll even do this. I'll put the 24 over 6. Well, these things can be reduced. So if I reduce these fractions, I get y is 1/3 x plus 24 divided by 6 is 4. So I can see this equation has a slope of 1/3 up 1 over 3. Ooh, yes, it does. And it has a y-intercept of 4. So that's this equation right here. The next one on the list is this one. So I guess I'll take away 3x from both sides first. So if I take away 3x, I'm going to get 6 times y is equal to negative 3x plus 12. And if I divide everything by 6, what I'm left with is 6y divided by 6 is y. This divided by 6 is negative 3 over 6, and then x, and then plus 12 over 6. And I can see both of those fractions can be reduced as well. So this is equivalent to y is equal to negative 1/3 x, and 12 divided by 6 is 2, so plus 2. So this is this equation. And again, why do I like it this way? Because I can see the slope and y-intercept by changing the format. This one I can change quite easily. I'll do it. I'm just going to take y, and that's going to equal negative 3x plus 20, right? All I did was I subtracted 3x from both sides. The last one, to get it in the slope-intercept form, let's see. What was it? That was y. I guess I'll take away x from each side. So if I take away x from both sides, this is going to become 1/3 y. And then on this side, then there'll be a negative x because I'm subtracting an x from each side. And then plus 5. And then I'm just going to multiply both sides by 3. So if I multiply the left-hand side by 3, it's going to just become y. And on the other side, when I multiply by 3, it's going to become negative 3x and then plus 15. So that's what this equation is. So having equations or being able to look at equations in slope-intercept form probably is more helpful in some ways. So the first question I'm asked is, which one of these equations has a slope of 1/3? Well, now that they're all in slope-intercept form, it's pretty easy for me to go through and find which one has a slope of 1/3. And it's the positive 1/3, right? The only one that has a slope of positive 1/3 is this one, right? Which is this one. So for that very first question, I'm going to say, oh, that's negative 2x plus 6y equals 12. That equation, nope, plus equals 24. 24. That equation has a slope of positive 1/3. The next one says, which equation goes through the point 6, 2? So that means if I put in 6, it has to equal 2. So if they're in slope-intercept form, right, if I put in 6 for x, the y value I get back has to be 2. I don't even want to look at the top equation unless that's my last choice. But let's think about my other choices. If I put a 6 in there, that's going to become negative. So I don't think this is it. I'm saying no here. If I put 6 into this, let's see. 2/3 times 6 would be 4. And 4 plus 2 is... Oh, no, I'm putting in 6. No, that's not going to be right. Because if I put 6 into this equation, if 6 is in there, 2/3 times 6 would be 4, and 4 plus 2 is 6. No, I'm looking for one that gives me 2. Oh, you know what? I'm just kind of going through here. If I put a 6 in here, 3 times 6 is 18. 18 plus 12 is not 18 plus 12 is not 12, so that doesn't work. What about this one? 3 times 6 is 18. 18, 19, 20. Oh, yeah. This is it. This equation, 3x plus y is 20. So when x is the number 6, 3 times 6 is 18 plus 2 more gives me 20. Yeah, that's it. The last equation here, oh no, I got 3 more. The next one says, oh, is perpendicular to the line, and this line has a slope of negative 3/2. So remember, if lines are perpendicular to each other, what that means is that they're meeting at exactly right angles, right? Perpendicular lines meet at right angles. And the slopes of perpendicular lines are, we always say 2 things, right? They're opposite and they're reciprocals. So we have to change the plus minus sign. So if it's negative, it becomes positive. If it's positive, it becomes negative. And reciprocal means that I have to take it and I have to flip it. So if it's A over B, it becomes B over A. So perpendicular lines have that property, right? Their slopes are going to be opposite signs and reciprocal. So what I'm looking for is I'm looking for a slope of 2/3. I need a slope of 2/3. And it turns out that the one equation that I didn't need to write in slope-intercept already had that. So this is y is 2/3 x and plus 2. And that's the correct answer because the slope of that line is up 2 over 3. It's the opposite reciprocal of negative 3/2. And the last one, second to the last one, says it goes through 3, 4, and 6, 6. Oh dear. 3, 4, and 6, 6. So I'm just looking at this. When I put in x is 3, when I put in x is 3, I should get 4. When I put in x is 6, I should get 6. And I think I kind of stumbled on it. I think it's this one again. Because if you can imagine, if I put the number 3 in here, right? If this is the number 3, 2/3 times 3 is 2, and 2 plus 2 is 4. So when 3 goes in, 4 comes out. So that's this point. And then let's check the 6, 6, 6 and see if it works. So if I put 6 into this equation, right, I have 2/3 times 6. Well, 6 divided by 3 is 2, times another 2 is 4, and 4 plus 2 is 6. So yeah, when x is 6, the equation gives me an answer of 6. So this point is also on it. So this one has the answer. Oops. It's the same as one above. It's y is 2/3 x and then plus 2. And the last one says, which equation is the same as 3x plus y is 15? Well, I did get them all in slope-intercept form, and if I was to take away 3x here, I get y is negative 3x plus 15. And I can see I've got that down right here. This is that equation. So the one that works is the very last one, right? These two equations are exactly the same. So this is x plus 1/3 y equals 5. And let's just say before we move on, like this is a pretty challenging equation, and I need to maybe revisit it a little bit and make it a little bit more appropriate for our particularly CP or basic class. But I think we can expect to see something in this genre that's a matching question. Let's move on to question 2. So question 2 says the first 3 terms of a geometric sequence are 5, 15, and then 45. 5, 15, 45. So one of the things a geometric sequence we know is that the generator involves multiplication. And in this case, right, we're multiplying by the number, I believe 3. And if you're ever not sure, one of the things you can do is just take your calculator and you take any term in the sequence. Like if I take 15 and I divide it by the value before it, 5, you can see I get 3. If I take 45 and I divide it by this value before it, which is 15, you see I also get 3. So that number 3 is called the common ratio, and it's also the generator for the sequence. It's how I move forward. So the thing says, write the next 4 terms of this sequence. Well, the last term I had, well, actually, let's just start with the first term. It's 5. So I'll hit 5 and I'll press enter. And every single time I go forward, I multiply by 3. So you can see 5 becomes 15, becomes 45. And then the next term would be 135. So 135. Oops, let me go here so I can write this. So the next term would be 135. I just multiplied by 5. The next term after that is going to be, I'm sorry, multiplied by 3. Multiply by 3 again, I get 405. 405. Multiply by 3 again, we get 1215. So 1,215. Then the last value multiplied by 3 gives me 3,645. 3,645. So those are the next 4 values in the sequence, and I just got them by continuing this pattern of multiplying by 3. The next question says, what is the generator of this sequence? Well, a generator is both an operation and a value. So for this one, it's multiply by 3. The next thing it says is, what is the 0th term of this sequence? So the 0th term is the term before this first term, right? My first term is 5. And to move forward, I multiply by 3. So if I want to go backwards to the term that came before, I would divide by 3 or multiply by 1/3. So the 0th term for this sequence would be 5 over 3 or 5/3. And then finally it says, write the explicit formula for this sequence. So for this particular sequence, by the way, I should be printing all of these in these boxes here. For the last part then, it says the explicit formula. The explicit formula for this one would be T of n, which indicates I'm restricting the domain just to the natural numbers. My 0th term is 5/3. And every single time I go forward, I multiply by 3. And I multiply by a lot of 3s, depending on which one I want to land at. So it's 3 to the nth power. That's the explicit formula for that geometric sequence. Our next question asks us to match some expressions that are given with simplified expressions. So you can see I've got a list of simplified expressions to the right, and to the left I have ones that are not simplified. So I think probably what I'm going to do is try to just go through and do these and then see if what I get is in that column on the right. So for this first one, when I have this negative exponent, I understand negative exponents don't give me negative numbers, they give me reciprocals, right? And one of the things we know is something raised to the negative power is the same as that exact same thing in the denominator. So this becomes the reciprocal, and it's going to be raised to the positive second power. Now I do need to square that denominator, right? Which means I've got a 3x squared times another 3x squared. 3x squared times 3x squared. I'll write it here. 3x squared times another 3x squared. That's going to give me 9x to the fourth. 9x to the fourth power. So this is what we're looking for this question. We're looking for 1 over 9x to the fourth. Is it here? Yeah, it is here. So this is definitely 1 over 9x to the fourth. The next one is, simplify 3x to the negative second. Another way to think about negative exponents and how to get rid of them is to multiply by a giant 1. So remember, if I take and I multiplied this by this value of 1, I selected it because I wanted to get rid of the negative exponent. In my numerator now, I have 3 times x to the 0 power, right? X to the negative second times x to the second is x to the 0. In my denominator, I have x to the second, right? That's right here. And of course, x to the 0 is just the number 1. So I end up with 3 divided by x squared. Is that one of my choices? 3 divided by... Oh yeah, it is, right here. So this is 3 divided by x squared. Next question says, okay, you know what? I'm going to do the exact same thing. I'm going to get rid of this negative exponent by multiplying by x squared in the top and x squared in the bottom. So that's going to give me 9x to the fourth power up in the top. And in the bottom, I'm just going to have just the number 1, right? Because x to the negative second times x to the second is x to the 0, which is 1. So I'm looking for just 9x to the fourth. Is it here? Oh, I just lost everything. Where'd those go? Here they are. 9x to the fourth. Yeah, it is. It's the last one listed. So this is 9x to the fourth. Oh dear. And then I've got this thing. Well, 9 over 3, right? You can see there's a 9 over 3. 9 divided by 3 is 3, right? And I can think about it another way, right? If I've got 9, which is 3 times 3 over 3, clearly there's a common factor of 1, or 3, right? Common factor of 3, so that makes a giant 1. So I'm left with just a 3 on the top. So this is 3, and then x to the, well, x to the fifth times x to the negative eighth would be x to the negative third. But we can't leave negative exponents in our answer, so I'm going to move that into my denominator, right? I mean, that's essentially what I'm doing. Or I can justify it by saying, look, I'm going to multiply by this giant 1. If you have equal things and you multiply by 1, you get something that's equivalent. In my numerator now, I just have a 3. And it's just a 3 because when I multiply x to the negative third times x to the third, that equals x to the 0, which is 1. And in my denominator, I've got x cubed. So I'm looking for 3 over x cubed. And it turns out... Oh. 3 over x cubed happens twice, right? I've already used it once, but it's happening again. So this is also 3 over x to the third power. That's cool. And then the last one looks a little bit more involved, but I mean, if I focus on the 6 over 2, right? 6 over 2 equals 3. So I've got a 3. Oops, I don't want purple. I've got a 3 in that numerator. And then let's look at the... Oh, this is also true. Look at this. Y to the fifth over y to the fifth. See how they're both positive? Because they're both y to the positive fifth power, like that literally is a number 1. So that's gone. The last thing I have to deal with is there's an x squared in the top, and there's an x to the negative second in the bottom. Now, those are not the same, right? I can't cancel those like I could do y to the fifth to the y to the fifth, because one of them's positive, one of them's negative. We're going to clear the negative exponent by just multiplying by x squared. That will eliminate that, and I'm left with, in the numerator, 3x to the, that's going to be to the 4th power. And the denominator is just the number 1, so I don't need to write it. So I'm looking for 3x to the 4th. Is it a choice? Yeah, it's the first choice. So this is 3x to the 4th power. Beautiful. Okay, let's move on. Next question is number 4. When we're asked for 4, there's, I think, 3 parts, A, B, and C. It says solve for y. So for this first equation, right, the couple things I see is I need to deal with these parentheses and use the distributive property. Right here, you can see that I'm multiplying a binomial times a binomial. So I perhaps might use a generic area model and think about the fact that I am multiplying a y and a positive 3 and a y and a positive 2. And when I multiply that, I get y squared. This is 3y, this is 2y, and this is 6. So that whole thing that I've underlined in orange is equivalent to y squared plus 5y, and then plus 6. Plus, I can see I have plus another 5y. And on the other side, I've got that this equals 21. And I'm going to distribute this negative across the parentheses, right? I am essentially, because I'm taking the opposite of something, I'm essentially multiplying this by -1. So what happens when I distribute that is I'm going to get a negative 2y and then a positive 7. And then also there is a negative 10 and then a positive y squared. So, wow, a lot of things. Well, first thing, right? Hey, I've got a y squared and a y squared on each side. So I'm going to subtract that from both sides. The other thing I'm going to do in this step is I'm going to combine the 5y here and this 5y right here. So if I rewrite it, just thinking about those two things, the left-hand side is going to become 10y plus 6. The right-hand side is going to be, let's do a little bit here. Let me underline this in blue. If I take the 21, the positive 7, and the negative 10. Okay, 21 and 7 is 28, and 28 minus 10 is 18. So I'm pretty sure this is going to give me the value of 18. And there's going to be a minus 2y. So next thing I'm going to do to both sides is add 2y. So I'm going to get that 12y plus 6 is 18. And if I subtract 6 from each side, we've got that 12y is 12y is 6, 7, 8. 12y is 12. That means that y is the number 1. Okay, so if y is 1, that's pretty easy for me to check on my own. So I'm going to take a stab at checking this. So I think y is 1. So that means that this is going to become 4 times 3. And then I'm going to say plus 5. Right? So 4 times 3 is 12. And 12 plus 5 is 17. So over on the left-hand side, it's pretty sure it's 17. On the right-hand side, if I put in a 1, right, it's 1. This is going to be a 21. If this is 1, this is going to become 2 minus 7, which is going to be -5. So, but I have the opposite of -5. So I'm looking at 21 plus 5. And then I've got a -10 minus 10. And I've got plus 1. So 21 plus 5 is 26. And 26, let's see if I combine these two, it would be -9. 26 minus 9 is 17. So I could have used a calculator to check that too, but because the number was just 1, boy, that was a lot to check. But I do get that when I put 1 in, I think both sides become 17. So I believe we're correct here. Let's move on to the part B. Part B says solve this equation for y. And I do notice that I've got x's in this equation. So my answer is going to have x's in it, right? There's no way to deal with that. If I want to solve for y, I want to get the y's all together on one side of the equation. So I think the first thing I'm going to do is I'm going to just combine those and rewrite it. So we'll look at 3x plus 4y equals 12. And then negative 6y plus 2y would be minus 4y. And then I would have a plus x. Okay, so let's get our y's together again. So I'm going to add 4y to both sides, right? So when I add 4y to the right-hand side, that's just going to become 12 plus x. I can see that, right? Because I had a negative 4y plus 4y is 0. That's why that's gone. On the other side, adding 4y, I get 3x plus 8y. If I take away 3x from both sides now, I have 8y equals 12. Let's see, x minus 3x would be minus 2x. And then as a final step, I need to divide everything by 8. So y equals 12 over 8 minus 2 over 8 times the x. And I'm fine if you leave your answer there. This does reduce. This is a minus 1/4, right? And 12 over 8, let's see, both of those can be divided by 4. So if I divide both by 4, I think I get 3/2. 12 divided by 4 is 3. 8 divided by 4 is 2. Yeah, so I get 3/2. So if I wanted to write this in slope-intercept form, I guess I would write y is equal to negative 1/4 x plus 3/2. All right, and then the last part for question, is this question 4? Yeah, question 4. The last part is this equation. This equation turns out to be an equation that involves a fraction, right? And we know that if I use the technique we've practiced, fraction busters, I can get rid of all the fractions. I can see I've got a factor of 5, a factor of y, and a factor of 2. So a great strategy would be to multiply every single one of these factors by, and I might even just write it like this, 5 times 2 times y. Right? And the reason why it's kind of nice to write it like that is I don't have to do a lot of arithmetic. But let's be clear, what I'm going to do is I'm taking this right here and I'm going to multiply every single numerator by that value. Right? Every numerator is going to get a 5 times 2 times y. So this equation is going to become 5 times 2 times y times 3 all over 5 plus 5 times 2 times y times 3 over y equals 5 times 2 times y times 5 all over 2. So what I get out of that is I immediately get to a point where I don't have any fractions. So you can see here 5 over 5 is a giant 1, y over y is a giant 1, and 2 over 2 is a giant 1. So if I look at what's left, my first term becomes 2 times y times 3, or 6y, plus 5 times 2 times 3 is 10 times 3, which is 30. And that equals 5 times 5, 25y. It equals 25y. I guess the next good step would be to subtract 6y from both sides. So this is going to give me 30 equals 25 minus 6, I think, is 19y. That means, ooh, is it? Yeah. That means that 30 divided by 19 is what I think y is. Now, that is definitely worth checking. So I'm going to fire up our calculator here. Let me just recenter this a little bit. So it doesn't matter that I've got x's and y's. I'm just going to store this as x and use the value of x, pretend that's just the one. The only thing I have is this one variable has to go there, right? So the fraction I have is 30/19. So I'm just going to add that, right? 30 fraction key 19ths, enter. And I'm going to store that into x. Boom. So now I know anytime I hit x, it's going to give me 30 over 19. So let me just try this problem. So I've got 3 over 5, that's 3/5, and I'm going to add to that 3 over, and I'm using the variable x, 3 over x. And when I do that, I get an answer of, So here's why I know we're correct, because when I plug in our value, you can see that I get exactly 3/5 plus 3 over x, and that equals 5/2. So without a doubt, as unattractive as it is an answer, 30/19 is the correct value for y. Okay, in question 5, it says Maceo, whoops, let me get rid of the calculator. Here we go. It says Maceo is given a recursive definition for an arithmetic sequence. So you can see the definition here. Remember how I read this? This is like, hey, this is a sequence that starts, the first term is 30. So I can write that down. The first term is 30. And then it says, to get to the next term, you take the term that you're at and you add 5 more. That's exactly how I read it, right? This n plus 1 means the next one. So it says the next one is equals, the next one is where you're at plus 5. So that means the next one would be 35. Add 5 more would be 40. Add 5 more would be 45. So those are the terms in this sequence, right? So it goes 30, 35, 40, 45. The next question says, what is the 0th term in this sequence? So the 0th term is the term before the first term. I know the first term is 30. And if I want to back up and get to that term that came before, right, I would subtract 5. So 30 minus 5 is 25. So my 0th term is 25. And the last thing it says here is, what is the explicit equation for this sequence? So the explicit equation, because it's arithmetic, it's just a linear equation. It looks a lot like y equals mx plus b. It has a slope, it has a y-intercept, but because it's a sequence, we often use this t of n notation, indicating that we're restricting the domain to just the natural numbers. So in this case, it would be t of n is equal to 5 times whatever n is plus the number 25. So this right here is what I keep adding each time, right? I keep adding 5. So when n increases by 1, it's not like I'm multiplying by n. I mean, I am multiplying by n, but what's happening to the sequence is I'm adding another 5. Multiplication shows repeated addition. So 5 times n, right, is just a shortcut way of writing add another 5, add another 5. If I have 5 times 3, what is it? It's 5 plus 5 plus 5. So this is exactly the explicit sequence for this equation, 5n plus 25. Solve this equation. Include a check for your solution. So this is an exponential equation, and to be honest, this is a pretty simple one because my bases are already the same. The only way that this can be true, right, is if my exponents were equal. So if you think about it, if you've got 4 to some power and it equals 4 to some power, the only way that that's ever going to be true is if these two powers are the same. So in this case, all I'm going to do is I'm going to set this exponent equal to this exponent, and I get what? I get x plus 3 has to be the same as 2x plus 1. If I take away x from both sides, I get 3 has to be x plus 1. And if I take away a 1 from both sides, I get, take away 1, I get 2 is what x must be. So x is 2. And again, if I plug that into these, I can see, this becomes what? This becomes 4 to the 5th power. And over here, it's going to equal 4 to the 5th power because 2 plus 3 is 5. 2 times 2 is 4 plus 1 is 5, 4 to the 5th power. So when x is 2, they both become 4 to the 5th, and definitely 4 to the 5th equals 4 to the 5th. What is 4 to the 5th? I don't know what 4 to the 5th is, but if I ask my calculator, it will tell me 4 to the 5th power is large. It's 1024. All right, next. Question 9, we are given an equation and we're asked to consider that equation, right? Consider the equation negative 4x plus 2y is 10. What is the slope of this line? Well, fair question. I'm not going to fall for the trap of thinking it's just negative 4 because this is not in slope-intercept form. To get it in slope-intercept form, I'm going to add 4x to both sides. So this equation will become 2y equals 4x plus 10. And then if I divide everything by 2, it becomes y is 2x plus 5. So I can see exactly the slope of this line. This line has a slope equals 2. So the slope is 2. What is the slope of this line? It's 2. And also remember 2 is the same as 2 over 1. I'm saying that because I'm anticipating this. So it says, hey, what would be the slope of a line that is perpendicular to this line, makes a right angle with it? Two things, it has to be opposite and reciprocal. So instead of being positive like this is, it's going to be a negative number. And instead of being 2, it's going to be what I get when I take the reciprocal of 2. So it's 1/2. So any line that makes a right angle to this line would have to have a slope of down 1 over 2. Question 10. So you have, on this question, we have 3 systems of equations. And it says, I want you to solve those by selecting the method you're going to use and then show the work indicating that you're really using that method. So again, the 3 techniques we've talked about are equal values, substitution, and elimination. And if I look at this first one, I would say that this is a good candidate for, I'm going to pick substitution. So I'm going to bubble in the substitution because that's what I'm using. And then let's see if I can show the substitution. So the second equation tells me that y is 8x minus 18. And what I'm going to do is I'm going to rewrite the top equation using this value for y. So this top equation is going to become 8x plus 5 times the quantity of y, which we know is 8x minus 18 according to the second equation. And then that equals 6. Therefore, 8x plus, ooh, that's large, 40x is equal to, I don't know, let me grab a calculator. Why don't I know? Well, I guess I don't know, I'm not good at party tricks. 8, it's negative 18. I have to multiply that by 5. I get negative 90. So this is minus 90, and that equals 6. Okay. If I combine those, that's going to be 48x equals 96. What did I do? I added 8x and 40x, and I got 48x. And then I added 90 to both sides. Now I'm going to divide both sides by 48, and it turns out 96 divided by 48 is nice. It's 2. So I have that x is the number 2. Now that I know x is 2, that's not the solution because I need to find the ordered pair, right? I need the x and the y. So I'm going to take this value of y and plug it into the second equation. The second equation says if you need to find y, it's easy. Y is equal to 8 times whatever you found x to be minus 18. 2 times 8 is 16, so I've got here 16 minus 18, which gives me negative 2, so y is negative 2. So my solution is 2 comma negative 2. X is, these two lines will meet at the point where x is 2 and y is negative 2. And just as a check, if I plug that in, let me grab the calculator here. If I plug that in, I should see that it makes both of those equations true. Not just one of them, but both of them should be true. So, for example, let me clear this. For example, the top equation says 8x. Well, x is 2, so I'm just going to go 8 times 2. And then I'm going to add 5 times y. 5 times, and y is negative 2. So you can see I use this to get the negative number. So 5 times negative 2. And when I press equals, it says 6, which is exactly what it said it should be, right? It said it should be 6. And in the bottom equation, it says 8 times x minus 18 should be whatever y is. So I'm going to go 8 times 2 minus 18. And I can see it definitely gives me that. So definitely 2 negative 2 is the solution. Our next system of equations that we're asked to solve is this one. And as I look at this, I want to solve this using elimination. They're both written in standard form. I'm going to have to modify it a bit, but I think this is the best way to go. So I'm going to solve this using elimination. And my modification is going to be that I'm going to take this top equation and I'm going to multiply it through the entire thing, both sides. I'm going to multiply it through by, I'm going to go -6, right? The reason why is if I multiply both of these by -6, my y terms will be opposites and they'll cancel. So let's go ahead and faithfully multiply it through the top equation by -6. So -6 times 6x is negative, whoops, let me get this calculator out of the way, I'm sorry. There we go. -6x times 6 is going to be -36 times x. And then I've got y times -6, which is -6y. I've got -6 times 11, which is equal to -66. And the bottom equation I'll write again. I've got 9x plus 6y is 12. So I have equal things, check. I'm going to add equal things, so I'm going to get equal things as a result. What I get on the left-hand side is -36 plus 9. Yes, I'm using a calculator. -36 plus 9 gives me -27x. And on the other side, I've got -66 plus the 12. That gives me -54. If I take -54 and I divide that by -27, I think I get +2. I do. X is +2. All right, so now that I know what x is, I have to calculate y. I think I'll use the second equation because it doesn't have a lot of negative numbers, I guess. So I'm going to write 9 times what I found x to be plus 6y has to equal 12. Well, this is the number 18, right? So I'm going to subtract an 18 from each side. So this gives me 6y is 12 minus 18 is -6. Absolutely. There's not a doubt. And if I divide both sides of this by 6, I'm going to get that y is -1. So y is -1. So again, we've got both values. We know what x is and we know what y is. So we can write our solution as the ordered pair 2, -1. That's the spot where those two lines would meet. And then our final question on the entire test, the entire study team test is this last one right here. It says, again, which method are we going to use? Execute on that. This one's clearly set up for me anyways, using equal values method. So that's what I'm going to use. The thinking is that it tells me two ways to represent y, right? The top equation says that y is x plus 15. The second equation tells me y is -3x minus 17. So I've set those equal to each other. I'm going to add 3x to both sides, so 4x plus 15 is -17. 4x is, yes, I'm taking my calculator and I'm entering -17, and I'm going to subtract from that 15. And when I do, I get -32. And now if I take the -32 and divide by 4, I get that x is -8. And now I just need to calculate what y is. So I can pick either one of these equations, right? They're great because they both tell me what y is. I'll use the top one. The top one says if you take y, that's equal to whatever you found x to be plus 15 more. Okay, so that means I've got -8 plus 15 is 7. So y should be 7. I essentially just tested it in the top equation. Let me check it in the bottom equation. So I'm going to have -3 times x. So that's going to be a -3 times -8, and then minus 17. That gives me 7. Yeah, so both of them check. So my ordered pair for the last problem on the test is x is -8 and y is 7. All right, there we go.